How can we improve political dialogue? And what does this have to do with discovering that the universe is behaving completely differently than expected? Why do we all cling to beliefs even when evidence pushes against them? What does this have to do with polarization? And what if the biggest problem facing humanity could be solved with practice? Today, we're going to talk with Saul Perlmutter, a Nobel-prize winning astrophysicist. But instead of the cosmos, we're going to talk about the inner cosmos. We're going to talk about polarization in society and how we might be able to address that with a different kind of thinking. Welcome to Inner Cosmos with me, David Eagleman. I'm a neuroscientist and author at Stanford, and in these episodes, we sail deeply into our 3-pound universe to understand why and how our lives look the way they do, and specifically today, why we think the way we do and whether we can improve our thinking. Okay, so imagine you've spent years as an astrophysicist, a space scientist, working to understand the universe out there. You've got a bunch of measurements. You have your instruments calibrated to exquisite precision. You've pulled in data from stars that exploded billions of years ago, these little pinpricks of light you can't even see with the naked eye. And you and your team have worked to stitch all of that together into a single picture. And finally, you pull all this into one place and you plot the data and you look at the curve. And something is off. Let's say it's not dramatically off, but the data just isn't landing in a place that it should. Now, this is the key moment in science, and it's maybe not what you expect, because in this situation, you don't jump up and shout Eureka and call a press conference. What happens instead is that you assume your graph is wrong. Because what we all learn in science is that if something looks really surprising, the most likely explanation is that you screwed something up. So you go back, you check the instruments, you look at all your assumptions, you tweak the calibration, you dig really deep to see whether there's some bias in how you collected the data or some stupid explanation hiding in the machinery. And you do this for days, and then for weeks and months, you keep rebuilding this graph, and it keeps landing in that strange place. So you refine the measurements, and the graph stays. You improve the calibration, and the graph just sharpens. And then very, very slowly, you begin to entertain the possibility that maybe the graph is right. What if the universe itself is doing something unexpected? Because you know that ever since the Big Bang, the universe has been expanding outward. Everything is rushing away from everything. But the pull of gravity should be slowing down that expansion over time. Like when you throw a ball up in the air, it goes up and then it slows because of gravity and eventually it falls back down. So the universe should be slowing down under the influence of gravity and eventually coming back together. Except your graph says it's not doing this. Your graph says the expansion of the universe is accelerating. In other words, something is pushing everything apart, something we don't understand, something we now call dark energy. Now, one of the key figures in this discovery, and who we're going to talk to today, is Saul Perlmutter at the Lawrence Berkeley National Labs. And that discovery that the expansion of the universe is accelerating completely reshaped our understanding of cosmology. And in 2011, Saul was awarded the Nobel-prize in physics. But here's the point I want to make right now. His big discovery came about as a long, uncomfortable process of eliminating every possible way that he could be wrong. And that's what scientific thinking is. It's not like what they teach you in high school science, where they tend to give science as a collection of facts. Instead, science is a way of thinking. It's a way of navigating uncertainty. It's a way of asking over and over, how might I be fooling myself? Now, this is deeply counterintuitive to how our brains usually operate because our brains are evolved to lock onto patterns and construct stories. A whole bunch of my episodes touch on this point that brains are always seeking explanations that feel coherent. And once we have a model of the world, we tend to protect it. We look for confirming evidence and we tend to filter out contradictions. But a scientific mindset asks for something different. It asks for a kind of intellectual humility. What it asks for is a willingness to say, look, I might be wrong. In fact, I'm probably wrong about a bunch of things. And the only way forward is to keep testing and keep updating. Now, when we look at the political world around us, that mindset of being willing to be wrong is starting to feel more relevant than ever because we are living in a moment saturated with information, but we struggle to process it. All of us take really complex issues and smush them down into binaries like us and them or good and evil. We all form teams, we defend our positions, and we treat uncertainty as weakness. But what if the ability to live with uncertainty is one of the most powerful tools we have for solving the mess that we're in? What if thinking in probabilities and revising our beliefs and engaging with disagreement, what if this is our way out of the hole? So today's guest, Saul Perlmutter, has spent his whole career grappling with uncertainty at the largest possible scale. But in recent years, he's turned his attention to something closer to home. He has zoomed in on this issue that scientists every day rely on a set of thinking tools that aren't always taught explicitly. In other words, scientists have ways of reasoning about uncertainty and evidence and disagreement. And Saul asked himself, what if everyone learned these tools? What if we taught everyone not just the content of science, but the process of thinking scientifically? Because the stakes are about how we all make decisions in a society, how we communicate, how we navigate a very complex, very interconnected world. So I started this episode with a conversation about a graph that didn't make sense, but today's show is really a conversation about how we come to believe something that overturns our expectations. And ultimately, it's a conversation about how a species standing on a small planet under an expanding universe might learn to think just clearly enough to build an excellent future. Here's my conversation with Saul Perlmutter. Okay, so Saul, let's start when you discovered that the expansion of the universe is accelerating. When you first got this idea about dark energy, what did that moment feel like intellectually? Was it excitement, skepticism, disbelief because of other things that you'd thought previously?
I think what people may not realize about the life of a research scientist is that most of the time you're trying to figure out what's broken. That most of the time you're trying to figure out, okay, what's wrong with my current setup? What's wrong with the data that I just brought in? If you're really lucky, you're trying to figure out what's wrong with the fundamental understanding of the universe. But that's really lucky, if you get to that point. And so when we first started seeing data that suggested this kind of unusual result, the first assumption is, okay, we're lucky that we've managed to piece all the parts together and we got a graph at all. Now we have to figure out, what parts of the graph to trust, what things we still have to recalibrate. And you just don't take it at all seriously when you first see it. You're just happy you got a graph. It's there's so many different elements of the story that you had to pull together, and so much data had to be collected, and you're so many calibrations that you had to do. Then the hard work starts, that you're starting to work on the next part of the hard work of trying to figure out, what do you believe? And finally, what happened after months and months is that the data kept sharpening up, looking stronger and stronger as we understood and calibrated everything. And it was starting to stay in this rather odd place that suggested the universe was not doing what we expected. It wasn't slowing down its expansion as you would expect gravity would slow it, but it seemed to be speeding up. And this is saying that finally, after months and months, we started to believe, okay, that's probably the answer. We're going to have to go public with this. So the moment of aha is a little bit hard to describe, right? Because it's not a aha moment, that instant. It's aha spread out over 7, 8 months. And so, but by the time you finally believe it, it's no longer a big surprise.
So the most interesting discoveries in science are often the ones that contradict our expectations. And so how does the scientific process train people, and you in particular in this case, to embrace having been wrong and having a new model of something?
Once you have in your mind that most of what you're doing is trying to figure out what's broken and trying to build up confidence in different pieces, in some sense, the idea that something is wrong with the big overarching theory is sort of part of the game. It's kind of what you're trying to do. You're trying to figure out, can we sharpen up our understanding of the world, and can we figure out, okay, which part have we not quite got right yet? And for the community as a whole, the huge excitements are whenever you figure out something that we all had thought was the case, and now we figured out something new about it. Your career is based on, as a scientist, is based on really doing trustworthy, very careful work so that people trust that the results that you're doing aren't just what you hope they would be. They're actually what you find, and that you are checking for everything that could be a mistake. And so that's where all this comes from, that ability to convince people that you've really looked for your own mistakes. And in some sense, probably it's the reason that science has had to learn how to work with people you disagree with, because they're the ones who are going to help you find your mistakes the most effectively. I could say in our particular case, there was a rival team that started working after we'd started this project. They started racing with us using the very, very similar techniques to get the result. And it was a very fierce competition, but that actually is what helps you. The fact that you have a group that's going to try to figure out where you're making your mistakes and you're trying to figure out where they're making their mistakes is one of the best ways to make that kind of guarantee that you've really hunted for where the problems are.
A lot of people, when they hear about dark energy and dark matter, they interpret that as ignorance, but scientists interpret this as progress. So why?
If your goal is just to prove things you already know, then it sounds like it's a big step backwards if you found that, what we thought was true is wrong. But that's so much not the philosophy of what you're trying to do in the sciences, in the big picture. You're assuming that there are things that we don't understand, and you're trying to figure out what they are. And so it's a huge success when you figure out that there's something that we had misunderstood, and that now we've honed in our understanding just a little bit more. So this is the kind of thing that just wakes, the scientists wake up in the morning hoping they do someday. They figure out something that overturns a piece of the puzzle, and that's really where the excitement is.
So you, in your career, sat in your lab and in meetings, and you realized that scientists seem to be using a set of core thinking tools that maybe the rest of society could benefit from. And so you, about 12 years ago, started a course at Berkeley. Tell us about that.
Yeah, so I think I was watching some political debate. This is, even before all the current, particularly strong polarization. But this is one where I think they were trying to figure out what was the right level to set the debt ceiling or something in one of these earlier periods. And it wasn't a particularly, vociferous, a moment. But even so, it struck me that the style of the conversation didn't look at all like the style of conversation that I saw at the lunch table of a bunch of scientists talking about almost any topic. And it included things like that probabilistic thinking that that we just discussed. There were all these different just parts of the vocabulary of how people talked that were, I thought, very good at helping think through a problem rationally and be able to handle just the logic of the question in a way that I thought was missing when you saw our society asking just a cold question about what is the right level to set a debt the debt ceiling in a society. That's not It's not a emotional question. It's just a question of what works best. And yet you are not hearing any of that kind of thoughtful discussion that you would see around any bunch of scientists just using the terminology that they would use. So I found myself asking, well, where is it that this terminology comes in? I mean, it's not like we're taught it in any physics, biology, chemistry course that I know of. And I realized that it was taught sort of by osmosis, as people go through a training as a research scientist, working with other scientists, they start to learn this vocabulary of ideas. And it just seemed to me that it would be really useful for everybody to know about it much, much earlier. Even if they were going to be scientists, they should learn it like directly, not just little by little through what people say. And then people who are not going to become scientists, they should be using this all the time. It's just a very useful way to have an approach that helps you think through problems in a very effective way for almost anything you do day to day, and for any business decision, any medical decision, any personal decision. These could all be useful. So that's what kicked off this idea for the course.
And so you hooked up with a couple of your colleagues and you started thinking about what are the scientific tools that could be useful for public conversation. And as a starting set, you came up with 23 of them. So give us a flavor of what sort of ideas would be useful.
Absolutely. And I should mention that my colleagues, John Campbell, a philosopher, and Rob McCune, a social psychologist in the public policy school, that I thought it was really important to bring people from other parts of the university together, because as a physicist, it's not like we have a monopoly on all these thinking tools, and that really you want to try to bring the best of what everybody's been coming up with. And we actually put a sign up asking people to come work on this developing the course, saying something like, are you embarrassed watching our society make decisions? Come help invent a course and come help save the world. And about 30 people started showing up. Like every week at the end of Fridays, we'd be there for a few hours before dinner, trying to come up with what would a set of concepts look like that would be helpful for everybody to have. So in answer to your question, I mean, some of the concepts were things like propositions are probabilistic. We know them, just as we were saying before, to some of it, we know for real strong certainty, 99.99%, some 60%. Other concepts were ideas like, when you look to understand patterns in the world and signals in the world of what's going on, it's very easy for our brains to see patterns that are just random noise, that things that will randomly to us appear like we've suddenly detected this relationship, this is causing this. A huge fraction of the time, it's easy to see that humans will just see a pattern that is not really there. It's just the random events look like a pattern to us because our brains are such good pattern finders. So that concept led to the idea of, what are the elements that we've learned about how do you differentiate those kinds of mistakes? And these are the issues of false positives and false negatives. When is it dangerous to think you've seen a pattern that's not there, but when is it dangerous to miss a pattern that really is there? And how do you balance those? And what are the techniques that people have developed to handle those? So these are three concepts to start with. Many of the concepts are very much these cautionary ones, how to avoid fooling yourself, because so much of science is built around the idea that we tend to fool ourselves. And so we're constantly having to develop these techniques to avoid doing it again. But there are other balancing concepts that we teach, which are techniques for keeping going and for some sense of optimism and forward motion, despite all that cynical need to avoid another chance that you fool yourself. And so some of the concepts include things like the idea that scientists have really, as a culture, developed a capability to have some confidence that you can solve a problem, and therefore you stick to it long enough to actually solve it. Because most people give up way too soon on a difficult problem. And that this is just a trick of the trade, is to have a little bit of arrogance, just long enough to be able to get you to the point of actually being able to take on big problems.
So let's step back to the first issue you mentioned about probabilities. So how did this come up at the beginning of the pandemic? What happened in terms of public communication of scientists to the public? That's where the issue of probabilities started really, the interface had a lot of friction there.
Now here I feel like there was a real missed opportunity because, and I should say, before I say anything else, I should say, if you are a public official and you're in a position that you suddenly faced with the pandemic, it's really difficult, right? I mean, and so people making mistakes, I feel absolutely no, sense of, smugness, though I would have done better. I'm sure that I would have done worse because it's really difficult to figure this out. But in armchair quarterbacking, watching it, from the outside, I would say that, there was a moment where you had a choice of being absolutely confident about what it was that you were going to tell the public to do. And I think that ended up being a trap, that you should not claim a confidence that you don't actually have, and that that you should put up with the fact that some people may be a little less willing to follow you in exchange for a really strong sense of honesty about, here is what we know and here's what we don't know, and we are going to play the odds. And when I said armchair quarterbacking, I realized that actually the metaphor of football plays could have been really useful, that I think it would have been a moment to have leveled with the public. And I think that people could have listened if you said, we're in a football game with the virus. We don't know its plays. It doesn't know our plays, but it will try to adapt to our plays. We're going to try to get ahead of it and come up with a better play, depending on what we see it doing. And so every week, every 2 weeks, every month, we're going to tell you what our latest play is. And then we're going to play it as best we can, and we're going to win this football game. Whereas if instead you say, we're going to come up with, here's the rule, this is what you guys should do from now on, and then a month later you have to change it because now we know something different. People say, well, you keep changing your mind. How do I know what to follow? But if you tell people this isn't a one-off thing, either we're right or we're wrong. This is a constant update that we're going to figure out its plays, and then we're going to do our plays. People would get it, I think, and I think they would follow you as you updated the recommendations as we learn more.
And part of the idea here is that generally the world doesn't think too much in probabilities, but in sports they do, right? That's your point here.
Exactly.
Yeah.
Exactly. And this is one of those things where we often feel like, oh well, how could the public possibly follow something so complex? The answer is they do it all the time in certain situations. And so all we need to do is have them recognize that, oh, this is another situation in which we have to use that muscle that we have, that thinking tool. And we understand it, in a sports context. Now we have to use it in this medical context. It's a little bit unusual, but it's really the right answer.
That's right. And people, all of us, often treat complex problems as binary. Why do you suppose we're so attracted to yes or no answers?
I mean, I've been trying to think about that a lot, as we've been discussing these topics. And to some extent, I think all of us have a little bit of the child in us, where we sort of remember those days in which our parents knew the answers. And where, if we weren't sure about something, our parents would say something and we'd feel safe. And I think we're all looking for that sense of, okay, well, let's just go find the person, the authority. They'll tell us it's right or it's wrong. They'll tell us what to do. And that's it. But, the world isn't that way. We grow up and we realize that actually many things are balancing acts, and many things we have to figure out how to play the numbers and play it as best we can. And that's where our success comes from, that sense of being able to go with what we learned. I mean, the other metaphor that I've been thinking about was, you wouldn't want to try skiing down a hill by just locking your knees, putting your weight in one position, and then just going. You actually shift your weight. You move things depending on what the bumps and terrain are doing. And nobody would expect to make it down alive if you just were rigid, all the way down a hill. You're reacting to it, and that's what we're very good at. I mean, humans are quite good at that if they know that's what their job is.
by the way, this thing you said about parents and being able to give you answers, Sigmund Freud famously argued that this is why we have religion, because when you're a baby, you've got these two giant creatures that care for you when you're in pain, they feed you when you're hungry, and eventually you grow up and that goes away and you need a replacement. I'm not saying this as an indictment of religion, but I think that's interesting to think about this issue of what we lose as we age and how we yearn for that kind of simplicity. Let me come back to this issue about our imposition of a model on random noise. One thing that's interesting is what we're doing is we're each taking our internal model and imposing it onto the random noise. Let's say in the political world we're talking about, we see some news stories, some headline, and depending on our neighborhood and culture and politics and whatever, we see that story and we say, this one case is an example of this much larger thing. So how could we, given that we're all yoked with our internal models that we've developed over our whole lifetime, how might we be able to see a little further beyond the fence lines of that?
So this is among those different conceptual ideas that we've been talking about, that we all need to use as our tools. One of them, of course, is a real understanding of the fact that we have a tendency to fall into confirmation bias, right? That we will tend to look for information that will back up our position that we already have, as opposed to look for information that will disconfirm it. And once somebody happens to give us information, we'll be much more skeptical of the information that that goes against something that we believe than the information that is just backing up something that we believe. And that knowledge that that's what we do, I think, is a really important element of scientific thinking of the kind I'm describing, because among other things, it's one of the reasons why we've learned in this culture of science to go work with people that we disagree with, that we go to conferences, we send our papers in for review, and people give us a hard time. And that's their job. They're supposed to be not our best friends for this purpose. They're supposed to be our best enemies, right? To put it in a strong terminology, their job is to figure out where the weaknesses are of what we're saying. And it actually is something that we learn from. And in the sciences, nobody enjoys when they get criticized, but they take it in and they actually try to improve their thinking by it. In the political context, it seems to me that the analogy that we've been really losing track of is that there's a reason that we would have a loyal opposition. There's a reason that we want to have people who are disagreeing with us in the room when we're making policy. And it's because there's no way that we're not making mistakes. We must be making mistakes. It's inherent in how complex the world is and how much we're trying to figure out. And to think that we will have a policy that must be right is bound to be leading us into danger zones of one kind or another. And one of the best ways to get at that is to have people who are going to disagree with the policy in the room, giving you a hard time. And I think that we've lost that. One thing that our current society has perhaps really not taken advantage of is the possibility of having good conversations with people who disagree with you and try to work through, okay, if I were born 25 miles away from where I was born, I would probably believe everything you believe, right? It's pretty clear when you just look at the maps of where people live and what they believe, that it can't be the case that I'm amazingly right about everything I believe. And if I happen to move 25 miles away and that's where I lived, I would be right, with some other point of view. That can't be, the whole story. And so I think we absolutely need to find ways again to become part of a single politics, where people consider it to be important to have a conversation and not scary, that they actually enjoy trying to figure out, if I believed that one little piece that you believed, I would switch sides. I'd be on your side. And they ideally would say the same thing. They would say, if that other thing you just said was true, I would be joining you. And you can't find that out unless you have a conversation. And once you find that out, you still have another job to do, which is to together try to figure out, okay, which of those facts is true, if that's the issue, or which of these priorities do I really do want to lean into, if that's what's differentiating you. But it doesn't happen unless you have that conversation.
Scientists really have to train themselves out of this instinct, because the fundamental intuition for all of us is that when something contradicts our beliefs, we have to double down on that. So how do scientists get themselves out of that instinct?
I think it's partly a question of where do you put your pride, and that ideally what you want is to not have your pride in always being right in everything that you currently believe. That your pride should be in being very capable of understanding which are the weak parts of what you currently believe, which parts are more likely to need to be revised, and pride in showing off the fact that you get a real kick out of learning something new that you didn't know before, and that's really where your sense of ego lies. And I think that's the funny shift that science helped people do. And I should say, it's all I'm describing is aspirational. It's not that the scientists individually always do this right. All of us fall into all these traps of confirmation bias and doing it wrong all the time. It's that the culture helps us not always do that. It helps us be able to sometimes show off our excitement about finding out that we were wrong on something, and that there's something else going on here that somebody has shown us. And the best of all is times when you find yourself that you're wrong, because then you can show off, how you did that. But I think it's something that you are taking advantage of a culture helping you shift this natural human tendency.
So let me ask you this. When we look at politicians, if they change their mind, that usually loses points for them, and people call them wishy-washy. This, changing your mind in science is a badge of honor. How could that spread more widely outside the ivory tower?
Well, this is something that I've been very much interested in asking. Is it possible that if everybody in high school, right, is supposed to be learning a little bit of, physics and chemistry and biology, people are supposed to have just enough of that, whether or not they're going to go on to the sciences, just enough so they can recognize what it is that we know about the world, and they can understand a little bit what's happening when scientists report what they're learning. For my money, I would rather trade in a little bit of the content of physics, biology, and chemistry in exchange for some of this scientific thinking. How do we think through problems? Because I think that would really help us be able to build a society where people, when they see one politician who's saying to them, this is a place where we do not know the answer. We're going to come up with an iterative way to get the answer. We're going to try this policy. If it doesn't work, we're going to update it with this policy. I want to build a society where people say, oh, that sounds a lot like how you think through a problem that I learned in high school, as opposed to saying that, well, that person sounds wishy-washy, and that's, I think, the long-term goal. Now, short-term, obviously, you want to have lots of people watch your podcast and try to get this out into the world, even now, for those people who did not get it in high school, just so they're reminded that there's something that's been very, very effective. I don't think we would have airplanes and GPS, and we wouldn't be able to go to the moon, and we wouldn't have all these capabilities if we didn't have this culture. And if people recognize how effective it is, I think they would also feel like, if they're running a company, the company should adopt this more actively as a culture. And as a society, hopefully then people would start looking for it in their politicians.
Okay, I love that. One thing we see, though, in society is that disagreement tends to be very tribal. And it strikes me that the difference might be, I don't have time to really get the data about the debt ceiling and this issue and that issue. And so it's easier in a sense to say, look, my skin isn't attached to, what happens in this war or that thing over there on the other side of the planet. And so I'm just going to go with my team here. How do we move things away from that?
I've been very impressed at the few places where people have come up with techniques that seem to get beyond that team playing. So there are these techniques of deliberative polling is one term that people were using. Citizen assemblies is another term people sometimes describe, where if you structure it correctly, you bring together a truly random set of the population, the way a jury does, and you organize how they will start to deliberate and on some question, some topic. where they are supposed to collect all the places that they don't know the answer as they're talking. And then they have a team of a panel of experts available to them that represent people who do know a lot about these topics. They may disagree with each other, but the jury of citizens can interview them and try to figure out what they believe and then go back and continue deliberating. And the experience that people have had when they've done this is that people don't get locked into their tribal associations the way they would ordinarily. Now they feel like they're a group that's working together to get an answer, and their job is to figure it out together. And apparently people identify with each other much faster when they're in that sort of situation, and they try to figure out without their badging and their sense of what team they're on getting in the way. Doesn't always work, but it seems to be a very effective technique when people have tried it.
What other principles could we take from scientific practice to reduce polarization?
So there are a number of things that we do know that can be helpful in this. I mean, one is that it clearly makes a difference if people have friendships and activities that they're doing with other people, and then discover that they disagree on something, because then they feel like they know each other. They know that they're not bad people. They're not trying to hurt anybody, and they want good. And so then they're more able to talk to each other. And so I think it does make a big difference if we have society where people are finding lots of ways to tie to each other, music and sports and art. And, there are many ways that people can, hiking, there are many things that people can do where they start to feel like they have a tie, and then they're able to have a conversation. So that's an element of the story. I think there's another element of people really using the scientific ability to be curious, that you want people to be thinking, not that their job is, when they find somebody to disagree with, their job is never originally to convince them that they're wrong. Their job is to talk to them and try to figure out, with this real curiosity, what is it that is leading you to your position, and how could I be in your position? What would make me agree with you? And I think that's the kind of thing that is a much more open starting point, and it makes it much more possible for people to have a real interesting conversation without getting angry at each other.
Do you see ways that we could structure conversations or institutions designed explicitly around this scientific style of having structured debate?
Oh, absolutely. I mean, I'm always a little worried about the fact that the only thing that people know about for like what do you do in school if you want to get people to have a discussion about some problem is you have them do a classical debate where they have to take a position and stick to it no matter what. I would love to see basically a deliberation society as opposed to debate society in out in the world and in schools, where the goal is to figure things out together and come to some common understanding, and figure out what would actually make everybody feel good about the solution rather than to win. And I think that would actually be a very interesting experiment, just to do that in the schools so that people got used to it as a different style to start with. I think in real life, I'm, if you don't count school, let's say adult life, I would be very interested in trying to set up more activities that felt like they encouraged this kind of thing, and that people had models of it to watch. So I was imagining, suppose you set up a reality game show where you watched pairs of people who disagree with each other together do a learning journey where they go and interview people, they talk to people, they have to do everything together until they come to some common conclusion about what they believe about something, and see what would happen. I bet it would be kind of fun to watch if it was played right, but in general, I do think this is one of the jobs of our society right now to ask, and the reason I'm bringing this up as a focus is that we're really good as a society at solving problems once we identify the problem. And, generally it's amazing the scale of problems that we can now handle. I mean, when I was a kid, 2/3 of the world was going to bed hungry. And apparently that's now down below like 8 or 9%. And the population has tripled or more, since that time. And we know nobody thought we could solve that problem of world hunger. And yet, once you understand the problem, people can take it on. Today's biggest problem, I think, is this problem of polarization and inability to think through problems together. And I think once we've identified that problem, now our job is to come up with the techniques and the solutions that will get people into conversation with each other so that they can solve problems. I think if we do that, we're home free. I'm not really afraid of, pandemics. I'm not afraid of, even comets hitting the earth and wiping out the population the way it wiped out the dinosaurs or something like that. I mean, we are amazingly capable, but the one last technology that we have to learn and the last problem we have to solve is this one, developing these techniques for getting people into useful conversation with each other. And we've seen great patterns, so I'm not worried about it being impossible to do. It's just that we have to take that on and do it. And we have to take it on while we're developing new technologies like communication capabilities of the internet, like the conversational capabilities with AI. All these things have to be used now for answering this last question. And if we do this one, then I think we're in great shape.
Oh, I love that. I couldn't agree more. I want to come back just for 1 second to this issue about debate and how when kids learn debate in high school, it's all about winning. There are, interestingly, for example, there's a Reddit channel where people debate each other, but the goal is to change the other person's mind, like any debate, but the person explicitly says, okay, I give you a point for that. You changed my mind. Here's a karma point for that. And so then people try to rack up as many points as they can. And that's kind of lovely because it ends with this thing of, hey, you changed my mind. Now, what happened is a Swiss research team about a year ago released some AI bots that ended up doing 6 times better than humans on this front in terms of changing other people's mind. And of course, everyone lost their minds and said, I can't believe there were AI bots that were doing this. But the really interesting lesson that nobody talked about was that the AI bots did not do anything in terms of misinformation. They simply presented their arguments more empathically and calmly and rationally. And it changed people's views on particular things. And I think there's a lovely lesson there about how we might actually become better humans by looking at AI in analogy to how we've done that with chess and Go and other things, by learning how to present arguments well and how to change our own minds, which I totally take your point that that's missing in high school debate.
No, I love that example, and I've really enjoyed that, the fact that there is that Reddit, both the original one and this story. Now, it'd be fascinating to know something that I don't know the answer to, which is if we look at how the bots were doing this, were they bringing in a unfair sample of the facts and managing to calmly change people's minds using a distorted subset of facts?
Apparently not.
Were they winning? Okay, so they were winning because they were actually helping people touch reality. And if that's the case, that's of course what we would love to keep using more and more of. And another example that of what you're describing was this study that was done where they tried to ask. They had conspiracy theorists talk to a bot, and the conspiracies, these were actually known to be false conspiracies, but they found that the conspiracy theorists were much more open to possibly being wrong after they'd had this conversation with the bot for a little, I think only four exchanges of a few minutes each. And I thought that was another good example where the fact that it was a calm situation where they didn't feel any ego involved in the interaction helped them just ask, well, but rationally, what do we know about the world? Is it possible this is right? Is it possible this is wrong? And I think that is something that we can learn from the fact that we have other thinking tools to play with, like the AIs. Now, it could go wrong. Obviously, in many ways, you can imagine it being used to make trouble. But I think this is one of these places where we really would like the AI researchers to be putting their thinking hats on from the point of view of what do we do to build something that will help everybody deal with reality in a much more direct way.
Yes, because a lot of conspiracy theories, I think a piece that's often overlooked is the social aspect to conspiracy theories. So if I tell you my big theory about the moon or JFK or whatever, I get to be the guy who knows something and I'm telling it to you. Even if you disagree with me, I get to be smarter than the rest and so on. But if you're talking to a bot, as you said about the ego, all that stuff is gone. I'm not trying to prove something to the bot. I'm not getting the social reward for convincing the bot that I'm smarter than they are. So I'm more open to listening. I think there's a real opportunity there, as you do.
Yeah, absolutely. And probably this is one of the reasons that you really don't necessarily want the bots in the end to become too human in these interactions. You want them to stay just clearly not human enough, long enough, so people can have a thoughtful conversation with them without feeling they're invested, in being right, in the same way they would if it was a human.
Yes. Okay, so I want to zoom the camera back out. Your physics work deals with the largest scales imaginable. Does studying the universe change the way that you think about human disagreements on Earth?
I had a violin teacher who I stayed with for, a big chunk of, many people do it, with music teachers, stay with a big chunk of your life. And they're very, they're very influential in terms of your philosophy of life. And I remember her telling me a story once about the fact that her father used to take her and her sister out at, I think it was like once a week, out to look at the stars and to talk about astronomy. And she said that years later, when she grew up, she asked her father, "What was that all about? You're not particularly a huge astronomy fan, and it's not in keeping with everything else you do." And he said, "Oh, I thought it was really, really important for you to not have a narrow view of the world, to be able to see the larger context of things." And to some extent, I think one of the real pleasures of doing things like cosmology is it brings everybody together around something that we enjoy thinking about, but it sets a sense of scale that we are just a part of a very rich world that we live in, and in some sense that we should be thinking of ourselves as what is it that would make us special and give us a interesting role in this cosmos, that we would like to feel proud about. We'd like to feel like we're building a world that we would feel represented something important and meaningful. And it's kind of interesting to do that in the face of the idea that we're such a small corner of such a small, galaxy, in such a small cluster of galaxies in such a gigantic universe that you could feel like, where is the meaning at all? But for me, it actually feels a little different. It feels like it gives us a sense of that we're unusually able to look out to this outer world. We're able to look into the inner world of the fundamental particles as physicists. That's something that we care about a lot as well. And somewhere in that, nestled amidst all these different scales, we exist, and we have the possibility of building something that feels meaningful. And so for me, it actually allows you to step way back, think of the big picture, and yet also feel like you have a responsibility out there to do something good.
So when you think about the future of humanity, scientifically and culturally and technologically, do you feel optimistic?
Well, I should admit, to start with, I tend to be an optimist in these respects, and maybe for no fair reason. And I can easily just state that ahead of time. However, I will also say that I think we have lots of good reasons for optimism. I feel like we have solved one problem after another that looked unsolvable. That once we know about a problem, we are, as a group. Now, individuals, sometimes yes, sometimes no, but as a group, we are amazingly capable. And that when you put a group of people together in a healthy, positive mode where their job is to disagree and work together, but they're going to solve a problem together, I have not seen problems that they have not been able to solve, and that you would never have imagined that they could solve. So that's for me the source of optimism. It's always a scary moment, right? Because we're aware of all the things that can go wrong, and we're also aware that at the moment we're not very good at getting on the same page, and we could easily hurt ourselves, hurt each other, if we can't do better than we are at this instant. But in the big picture, stepping back, we've come together after many times where we've fallen apart as societies. We've come back together and we've managed to build things, and and I think we just have to do it again. And I think that's why I'm optimistic, because I think that we've done it before. We can certainly do it again, and we have all the tools we need. That's not the problem. I think we just need to get everybody able to think together and not feel too married to everything they believe having to be right, but being able to enjoy walking around the problem with some other people just long enough to solve it.
So if you fast forward 100 years from now, what do you hope humanity has figured out that we haven't yet?
If we manage to pull this off, if we manage to get ourselves into a mode where we're actually thinking, even, it doesn't have to be everybody, but even just enough of a core of people who are trying to solve problems together, I imagine that we'd be living on a planet where what we're really worrying about is how do we make sure that everybody on the planet is healthy, is given the opportunity to be creative and to work on things besides just bare subsistence survival, that they're actually being able to think about what kind of questions would they like to ask, what kind of creative projects would they like to work on. I think it's perfectly possible if we did this right, that 100 years from now, that would be the challenge. That we say, oh, look, we just found that, we've gotten it kind of right in these parts of these countries. Now we just have to get, the help this group over here that hasn't quite figured out how to do it. They have some good ideas of how they would like to do it. Let's give them a hand. I feel like we could be in that position where we were looking around and asking, where are the last pockets of unhappiness that we could possibly help alleviate, and bring a society where the only problems are the fact that humans are human and we're going to always have our ups and downs, but that we have a chance that everybody has an opportunity to be doing something productive together. I just imagine that it would feel like such a pleasure for everybody at any current position in our current world, that they would all feel this pleasure if they felt like they could walk down the streets and feel they were part of a planet that was thriving in that way, was making it possible for presumably our ecosystem of other animals to be doing well, and that we were also now beginning to think more about where would we like to explore, both intellectually, but perhaps visiting other parts of the solar system, eventually more. There's a lot of room for us to be feeling something very exciting at this moment, and I wish that people had that sense that this is their opportunity to do something positive, not just to be scared of all the things that go wrong.
That was my conversation with Saul Perlmutter. We started with astrophysics, but we quickly got ourselves to how we hold our beliefs. What Saul noticed a long time ago is that science has developed over many centuries a very particular culture around belief. It's a culture where you want to be uncertain and where disagreement is not something to avoid, it's something to seek out. Now, that's really unusual because in most areas of life, we build our identities around what we believe. We attach ourselves to ideas and then we defend them. We double down when our beliefs are challenged. But in science, the game is different. The goal is not to be right, it's to get it right. And getting it right requires the ability to step outside your own perspective and to examine your own beliefs as though they might be flawed. We invite criticism, which never feels good, but we do it because it sharpens the picture. And it's hard because it runs against deep instincts. As I mentioned at the beginning, our brains are pattern finders. Our brains build internal models of the world, and once those models are in place, they tend to become self-reinforcing. We catch the evidence that fits, we discount the evidence that doesn't. So, what do we do about this? The answer that Saul suggests is the scientific approach. You build systems that help you wriggle free from your own biases. You invite people who disagree with you. You create structures where your ideas are challenged and refined. In other words, you make disagreement part of the process. And when that works, perhaps we get a future where humans can think together better. We can collaborate, we can disagree productively, and we can update our beliefs as new information comes in. Saul's hope is that if we can do that, then many of the big, overwhelming problems we face become tractable. And history gives us lots of examples of this. Problems that once seemed insurmountable, like feeding a growing world population, or getting rid of smallpox, or getting ourselves to the moon, all these problems yielded when enough minds worked together in the right way. So, what I take from today's conversation is that the biggest challenge we face probably isn't any particular problem out there in the world. It may be the meta problem of how we think about problems, how we talk to each other about them, and how we navigate disagreement. Because if we can get that part right, all the rest will fall into place. Go to eagleman.com/podcast for more information and to find further reading. Join the weekly discussions on my Substack, and check out and subscribe to Inner Cosmos on YouTube for videos of each episode and to leave comments. Until next time, I'm David Eagleman, and this is Inner Cosmos.